Why is the sun? The moon and planets are chasing each other in the same orbital plane. We humans have noticed this for a long time. What does that mean? In fact, there are fixed stars in the sky. While the positions of the other stars are constantly changing, they were always chasing each other along orbits of celestial bodies that seemed unchanged for hundreds of years. The moon is also moving along this trajectory, and he seems to be following the sun as well. Until people realized that our stars were static, and the Earth rotates like all the other known planets. Ancient observers are witnessing a strange thing. Those fixed stars filled the entire sky. They can shine wherever they want. And those moving stars are the planets. It seems to be forced into a very fine, fictional in-band movement around the entire ball. This belt came to be known as the ecliptic, because only along his path, a solar eclipse occurs between the sun and the moon, and immediately associated with the so-called zodiac, which identified planets, the 12 constellations that the sun and moon pass through. The ecliptic was of great interest to early astronomical observers, because he's obviously full of meanings related to astrological numbers and divination based on the positions of the stars. When John Xingshu's mysticism gave way to science, it became clear to them that the zodiac had meaning. But that's astronomical. At Kagolor using his laws and Gala using his telescope. After thoroughly determining the true nature of the wandering star, things suddenly became clear. All the planets orbit the sun in the same plane. It's no accident. In fact, it can be expected that orbits are randomly oriented because attractive forces keep planets in these stable orbits. It works the same way in all 3 dimensions of space. So we see this sort of humming arrangement of bees around the hive. It's not a nice orderly series of near-perfect circles. Would be more normal? It's a lot more than normal. Because somebody did the math. There are 8 planets in our solar system that orbit similar planets. The probability is about 1 in 30 billion. Apparently, this peculiarity must be related to the origin of the solar system itself. But what exactly is the reason? The answer to this question is quite complicated. It involves several important physics concepts that we will learn together. Are you ready to go back billions of years? A long time ago, when the star formation rate of the Milky Way nearly reached its maximum. It started happening on one of his innermost walls, which was very normal at the time. But there's also something very special about us. In fact, what we now think of as celestial apartments is about to take shape in the solar system. And as we'll see, this structure doesn't just last a day, a century, even 10 years or millions of years. The time it takes for the sun to form and begin to become a reassuring main sequence star. On human timescales, 10 million years seems like an infinite amount of time. But in fact, it only represents 1/1000 of the age of the universe at that time. Then again, all we're going to describe is slow. These phenomena are incomparable. Our story began 460 billion years ago, at a distance of 27,000 light-years from the center of the Milky Way. A hazy cloud lazily orbits. According to our standards, it's a huge gas. Mass extension of 50 light-years or 100 light-years, although it is only about 1/1000 the diameter of the entire galaxy. Its density is usually 100 magnetic components per cubic centimeter, could rival the most powerful vacuum we have on Earth today. And it's incredibly cold, just a few degrees above absolute zero. This may seem strange, but the origin of the solar system was entirely in this icy cosmic vacuum, temporarily suspended in darkness. Such a dark scene is reminiscent of certain passages in Fred Hoyle's novel Dark Clouds. Darkness surrounds the abyss. The Spirit of God is hovering above the water. But this is a video mainly about astronomy, so we need to get this straight. The soul of God is composed of 73% hydrogen molecules and 25% bad molecules. The remaining 2% is carbon, nitrogen, oxygen, and silicon compounds. In fact, so did the thousands of other nebulae that then covered the Milky Way's disk. However, at some point, something broke the silence of the clouds. The denser areas begin to collapse under the pull of attractive forces. According to the most widely accepted theory, something can come into close contact with a massive star. Radiation from nearby sacrificial stars or shock waves from one or more supernova explosions. In fact, it is in a state of dynamic equilibrium between the thermal energy of the ion and the attractive force. The former tend to disperse them, and the latter tends to keep them close together. If this balance is upset due to internal currents or external reasons, instability can occur. In some parts of denser clouds, attractive forces may weigh on internal pressure, causing attractive force collapse, and produce something very different from the cold gas cloud. No matter what his origin is, in fact, the effect of this disturbance is to transform clouds. Fragmentation thickens it into hundreds or thousands of little balls. Each ball is about 1/10 of a light year in size, more than 100 times the size of the current solar system. Each generates a star. Remember that stars are not born in solitude. It's about hundreds of individuals coming together into the world. In our most interesting sphere, gas continues to collapse, warming in denser regions, and a disassembly formed around him, formed by material from primordial clouds not yet involved. It's made of atoms, dust composed of molecules and ground meat elements. Slowly, the center of the sphere begins to contract. The rotation is getting more and more obvious. In fact, throughout the entire cloud, they don't happen at the same time with the same intensity. The first clouds were very large, so much so that he allows different falling speeds in different areas. So at some point, as in the downward draft, formed a preferential rotation. As a result, the cloud started spinning and squeezing faster and faster. This phenomenon is determined by the important principle of conservation of agitation. According to this principle, in the absence of external force, the amount of agitation and the measurement of the strength of rotation of an object around its flush axis do not change with time. So while our primordial cloud initially rotates very slowly, but as quality becomes more concentrated, it's getting smaller. His rotation speed will increase. Centrifugal force due to rotation. Matter does not travel all the way to the center where the sun is ignited. It's spread around, forming a striking disk with a radius of at least 100 astronomical units. The latter then splits into smaller parts. Each section begins to collapse and rotate independently. Take away some of the overall initial angular capacity. Collapse and aggregate to form so-called planetesimals. This is a solid with a volume of only a few kilometers. Body, they form around heart again. This was the precursor to the shape we know today. So here's the big picture, but some aspects of the problem require better definition. For example, when we say that the planets orbit the sun in roughly the same plane, what do we mean by roughly? In fact, the alignment is not perfect. From an absolute perspective, The difference between the most inclined orbit and the least inclined orbit is only 6 to 7 degrees. And its exact value depends only on the reference system we use to calculate these differences. Here we learn that, in addition to being completely fictional, Huangdao County, it's just a frame of reference. In fact, the ecliptic plane is nothing more than the orbital plane of our planet. It is from this hypothetical plane we start calculating the tilts of the other orbits. This shows that, according to the definition, the inclination of the plane of the Earth's orbit is equal to 0 degrees. Mercury's angle is 7 degrees, Venus is 3.4 degrees, Mars is 185 degrees, Jupiter is 1.3 degrees, Mars is 2.5 degrees, Uranus is 0.77 degrees, Neptune is 1.77 degrees. But we only use these values for computational convenience, because they don't fit the reality based on the physics of planet formation. In fact, we are talking about a purely conventional practice, because we humans like to be at the center of every unit of measurement and calculation. If we want to calculate the inclination of the orbital plane in the equatorial plane of the Sun, things can change dramatically. The Sun's axis of rotation is not perpendicular to the orbital plane of the planets. It's definitely tilted. Until now, no one has come up with a happy explanation for this bias. Now, the possible explanation for this is due to the hypothesis that there is a large planet. Some astronomers think he might be orbiting the Sun. The inclination is 30 degrees, a few hundred astronomical units from the Sun. Since the beginning of 2016, all astronomers are trying to locate this planet known as the ninth planet. His existence at the time was based on the assumption of an attractive force anomaly for objects beyond Pluto. It could influence the alignment of the orbital planes of other planets over billions of years. And here's a digression. We said that if the inclination of the orbit is calculated according to the equatorial plane of the Sun, then everything will change. The plane of Earth's orbit will be the most tilted. It's 7.1 degrees and Mercury's angle is 3.4 degrees. Venus is 3.9 degrees. Mars 5.7 degrees. Jupiter 6.1 degrees. Puxing 5.5 degrees. Uranus 6.5 degrees. 6.4 degrees of Neptune. It's really weird, isn't it? Of course, all of this applies to planets and all other objects that form in sucking disks. For example, the large moons of gas giants. They lie almost entirely in the plane of rotation of their planet. And then the little latter, such as asteroids and comets. In the most extreme case, their orbital inclination is very high. Dwarf stars Pluto and dust stars, although they are really big, but their orbits are tilted 17 degrees and 44 degrees, respectively. Obviously, the birth or attractive force of all objects is very different from that of other celestial bodies. What do you have to say about that? Please leave a message in the comment area below. The video ends here. Thanks for watching. See you next time.